Okay, so I think we're live. Welcome. Thanks for joining. If you're joining live or if you're watching the recording later. Today we are going to follow the series that we started a couple of weeks ago of ways to run Kubernetes in an easy and not a lot of resources needed way. This is useful for developers who want to try things in Kubernetes or for IoT devices, things like that. Today we are going to be showing a canonical distribution, so from Canonical, called MicroK8s or MicroK8s, that they claim to be autonomous low ops Kubernetes for clusters, workstations, edge, and IoT. Because it has the micro on it, it seems to be a good way to also run it in our laptops, and that's what I'm going to try today. Following the same pattern as the other streams that we've seen, we are going to try to install it, and then we are going to try to deploy Datadog in it to see how it looks like in Datadog as well. Okay, so let's have a look. So they claim to be super simple, high availability, self-healing, has some plugins here. Let's see how we can run it on macOS. So the first thing that they say for macOS is to install Multipass for macOS. Multipass is another software from Canonical as well. It's basically a VM management tool. They say that it's specific for Ubuntu, and actually it's a lot easier if you want to use it for Ubuntu, but actually it's just a VM management, so it could work with other type of operating systems. We are going to do this as they claim in the documentation, so we are going to do this using an Ubuntu VM. In the case of macOS, this management VM management tool, basically what it does is to use HyperKit VM. So we already have that. So the first thing that it says is that to launch an instance, it will have a name and some memory, 4 gigabytes here, and 40 gigabytes of disk. So let's copy that. And let's do that. We are not going to change anything, not even the name, just try it that way. So I guess it's creating the Ubuntu VM, and it's probably going to take some seconds to do that. Okay, that's done, which is pretty fast. You can see it's already running. It has an IP, and it's running Ubuntu 18.04. Today, I think 20.04 was released, so probably this will be updated pretty soon to be 20.04 by default. Okay, cool. Let's move on. So it seems like Multipass has an easy way to SSH into the machine with this command. So let's do that. Okay, we are here again. If we do this, we're running 18.04 and a 4.15 kernel. All good, clear here. And let's install MicroK8s. So MicroK8s is distributed as a snap package, which is a packaging system for that was created as well for Canonical. It's mostly used in Ubuntu. It has support for many other Linux distributions, but I'm not sure if packages like this will be as well tested in a different distribution as in Ubuntu. So basically what we are going to do here is to deploy this snap, and we are going to do it as in classic mode. So snap is a packaging system that in general, packages are confined in the sense that you have to give specific permissions in your system to do stuff. But for packages that require a lot of things to do on your computer, like this one, which basically will require the Docker socket, things like that, they have this classic mode, which is basically unconfined. It's just like any other package. So let's install that. So it's going to download first the core snap, which is required the first time that you install a snap in your Ubuntu system. And then probably it's going to start downloading and installing the micro Kubernetes one. So once that's done, let's check what we have to do there. Okay, so it seems like when it's installed, they start creating all the processes. So they have a command here, which is very handy to make sure you don't do stuff until everything is ready. So they have this status command that will give you the status of your cluster. And they have this option, wait ready, that it's going to wait until everything is ready, I guess. Your kubelet is up and running, your Kubernetes API server, etc., etc. So basically your node is ready. So let's wait until that's done. And then it says that you have to turn on standard services. Like so the way MicroK8s works is that they have a set of add-ons similar to what Minikube has, that hopefully are well tested, that you can install things in your Kubernetes cluster that you may need in an easy way. You can, I guess, enable DNS will deploy core DNS. I guess you can do it with the normal core DNS installation process, but this is a way to do it a little bit better. Okay, so this is now running. So it has as I said, the different add-ons. Let's see. So it has its own kubectl that has all the certificates already created. You don't have to. You can, if you want, to use kubeconfig if you want, and we are going to see that in a second. And let's get the nodes. Okay, so the node is ready. It's running Kubernetes 1.18.1, so pretty up to date, which is very good to see. What else we are going to do? So we are going to see help here, see what we have. Okay, we have enable help. So here we have all the add-ons that I was talking about. So we can deploy core DNS. Let's do core DNS at least, because probably we need that. Cool. And let's do also a storage class. We are going to deploy PostgreSQL as part of this. Well, and probably will need a storage class So basically what it's going to do is to create a default storage class. So when you do a volume claim, it's going to create automatically for you a host path, which again, it's handy if you want to try things quickly. Cool. Let's see how this looks from I'm going to create an alias, because if not, I'm going to be typing this thing a lot, or better, just K. See if this works. Okay. So this is the first thing that it's interesting. So when checking for pods in the kube system namespace, we only have the things that we enable afterwards. We only have the core DNS pod and the host path provisioner for the storage class. But we don't have anything else. We don't have the Kubernetes API server or all the things that can be deployed as pods inside the cluster. If we check the different processes in our VM, in our Ubuntu machine, we can say that everything that the Kubernetes cluster requires is deployed as a binary, basically a systemd unit instead of as a pod in the cluster. So we have the kube control manager, we have flannelD, which basically means that we are using Flannel for the CNI. We have the scheduler. What else we have around here? We have the kubelet, of course, that has to be a binary anyways, kube proxy, and the API server. So all of that is running directly as a binary. Okay, so the next thing that we would like to do is to deploy some manifests into our cluster. But the thing is that if we get out of the VM back to my laptop, we are not going to be able to connect to the cluster directly. So the way we can do that, and this is different from when you, for example, deploy something with Kind or Minikube, where all this the kube config is already made for you, so you can directly from your laptop connect to the cluster. So in this case, we need to do it before. So one of the commands that it has here is to generate kubeconfig. So here is the kubeconfig. So what we are going to do, and this IP, we can connect from it directly from outside. So what we are going to do is to move this to a path that we can remember quickly and easy. And we are going to try to connect to that. Multipass has a way to copy files. So let's see, what is that? Okay, let's check. Transfer, okay. Not enough arguments given. I would hope that a good CLI would give me what parameters are missing without me having to type help, but it is what it is. Okay, so multipass list, what was the name? MicroK8s VM. Multipass, transfer, and then the source, which is MicroK8s VM config. Here. So I'm going to transfer that kubeconfig file into my laptop. Let's see, it's here. Okay, it's here. Cool. So now I can do now things like kubeconfig is going to be this config. Let's check that this works. This is not going to work because I didn't export it. Okay. So now we are able to connect to that Kubernetes cluster from my laptop, which is usually what we want to do when we are developing our applications and we want to try them out in Kubernetes. Again, I think this could be a little bit easier if this was done automatically. Okay, let's check the classic e-commerce application that we normally deploy. So we have a deep database, Postgres, and some services. So let's do that. Let's apply that. Okay, so you can see that as part of the deployment of the database, we created a volume claim, so and a PV and a PVC, and it seems to work, which is good. And let's wait until this gets created. It's not super fast, as we can see. While we're waiting for this, let's check on the docs. Let's see what we can see here. Multi-node cluster, this is interesting. So it seems like you can actually add nodes. If we have time at the end, we can try this. What else we have here? We have add-ons. So we have Cilium. So that's really interesting because Cilium is pretty new. It's using eBPF, so it can be a good way to try it out. We have Home. We have things like Knative and Kubeflow. So it seems to have a pretty handful of plugins to try it out. Let's see the common issues. Configuration, running, checking logs. Okay. Let's see how this. We only have 2 pods running. Okay, this is going to take a while. What else we have here? Configuring micro Kubernetes services. This is what we were talking about. Most of the Kubernetes components, the components of your cluster, are going to be running as services in systemd. So it seems like if you want to configure them, this is what you need to do. So basically what you need to do is to get the unit file for that particular systemd service. So if you're not familiar with systemd, this is going to be a little bit tricky at the beginning, but once you understand those, it's pretty straightforward. So basically what you need to do is to edit the unit file for systemd and restart those services. So it explains all the different services that it creates, the API, containerd to run your containers, controller manager, etcd, Flannel, the kubelet, the daemon proxy, the scheduler. So again, all of that is going to run as a systemd service, not as a pod. Okay, now we are done, which is good. So let's see if we can do things like port forward easily. and whether it's fast enough so it doesn't time out. Ah, cool. Faster than I thought. Okay, so it seems like our app is up and running, our e-commerce app. And now what we are going to do is to deploy Datadog. And for that, the first thing that I'm going to do is I'm going to jump into a window that is not on screen. So I can deploy the secret with my API key. So, and you cannot see it, which is what we always do. Okay, the secret is created. So we have it here now, the Datadog secret. Again, I just created this, but I did it on my secondary monitor, so it's not on screen. And let's apply Datadog. So it creates a cluster role and a cluster role binding for the Datadog agent to have all the permissions needed. And it creates a daemon set. Okay, so the Datadog agent is creating, so probably it's going to take another little while. So let's wait for a second. Let's continue checking. So the code is for MicroK8s is on GitHub. It's written in Python. Basically, it's going to use those different binaries. One of the things that they don't, well, I didn't mention, this is again a certified Kubernetes distribution, which basically means that it passes all the tests that the CNCF recommends for you to decide that a distribution of Kubernetes is actually Kubernetes. And they have to run this test for every version of Kubernetes, which it's really good to know that, for example, this particular distro of Kubernetes is going to keep up to date with all the different new features that are coming up. Okay, now it's running. Let's see that we are going to run the agent status command to make sure that everything is running. Okay, so we get the logs and the different checks. Oh, the kubelet doesn't work well. Kubelet. Something that we will need to investigate. And Docker again is not running either. Probably a configuration issue. We will need to check it out. Let's see if APM is actually sending data. So we will need to wait a few seconds. Let's see the host map. Okay, we have here, at least we are getting data from the system. So we have the VM with Datadog agent running. And obviously core DNS is also there. Let's check the containers that we have. For example, by deployment. Okay, so we have all the deployments here that we have. As you can see, it doesn't have any of the usual like kubeproxy and other containers that we said. This is created by systemd services. Let's see the processes that we can see as well. Okay, so everything is up and running. I don't see why APM is not showing up yet. It's interesting. Probably a problem with the. Let's see if we can see something in the logs. Okay, this is the problem with the kubelet check, but that shouldn't affect APM. Let's see if we are getting traffic. We generate some traffic here. So we can start seeing traces. Okay, so it's generating traffic and it's sending it. So probably it's just a matter of time until it appears here. No, it's not sending the spans. The Docker check, probably this is not where the Docker socket is. So we will need to modify the configuration. But APM, I'm not sure what is not sending traces. The trace agent is running. Doesn't seem to have any. Let's see. see if it can connect to the agent. Yeah, seems connection working fine. Weird. Okay, there seems to be a lot of things that doesn't work out of the box with micro Kubernetes. So we have system data, but we don't have the Docker check working out of the box. And we don't have the kubelet. We have an issue with the kubelet one. So what we're going to do is to do a second round of this stream early next week or tomorrow to see if we can fix it. Thanks for watching.